All right, I thought I would just go over this AC. It should help you prepare for the test. I'll just, I already calculated everything, but maybe with highlighters and whatnot, explain how I went about it. So the first, in this scenario, we want this side Y here. And I particularly stick with this triangle right here. Couple of reasons, right? Why? Anyways, it's that slant of this right triangle, and I have this side length right here. So I use what I can to come up with that Y there. And notice that the 30 here, up here, that 30 belongs to this triangle. And remember, the sum of interior angles of a triangle is always 180. I know 30, I know the 90, which allows me to figure out 60. So once you have this, this angle here, you have a pair. Okay? These are paired up like that. And notice that cosine law would just not work. You only have one side, so immediately you kind of rule out cosine law and try to see what you can do with sine law. So here's my pair. I paired it up, and then I use sine of 90 degrees to figure out y. Okay, and there you have it. Next is asking for the value of angle Z. Z is just this little sliver here. So we know that it's 45 here and 30 there. So if we subtract these two angles, we're left with just this little wedge. So that'd be 15 degrees in this case. Distance between the two tigers, so we want to know this distance right here. Okay. That's this one right here. And remember, we're now dealing with this triangle, which is an obtuse triangle, right? How do I go about it? I try to fill it in with as much information as possible. So you have the 120 here because these are supplementary. They're right next to each other along a straight line, so that's 120. You take the 60 away from 180, essentially. Once you have that, and the 15, remember, we use sum of triangle is equal to 180 to figure out the 45 as well. So try to figure out as many angles as possible. And why would we want to do that? Well, now the y, remember, we're inside this triangle here now. The y is across the 45. Okay? And we know what y is already, 75.06. So I use sine of 45 over that side. Sine of 15, okay, 15, that little angle is across the side that I want. And that ends up being 27.47. Okay, so hopefully that helps you out. So a lot of properties of angles, supplementary angles, and then also sum of angles in a triangle help us out here. In this particular case, angle K, right, we know that it's 60 from here to here and 25 from here to here. So if we want that wedge here in between, that is 35. We just subtract the large and the small to get 35. They're asking us to figure out the distance between the supports here. And you should notice that you have this side length, that side length, and now you have the angle in between, SAS. Okay, so just plug it in using the formula for side angle side. Remember, it's 35 here, and then you solve and you get your side. Next question here, it's the same tower, support tower, but now there's a little bit of a different spin to it. So lots of things going on. So maybe with a highlighter, I will help you out here. Angle K, again, it's 55 minus 25 to get K, right? We just want that angle there, and that's the 30. So in a sense, we can write that in here now, that we know that this opening here is 30 degrees. Okay. Calculate the length of wire Y. So that one is way out here. So you kind of are, yes, you can work with this triangle if you wanted to, but it's kind of pointless because we don't know a single side length of this one. We do know the 87 is down at the bottom here. So I'm going to use this big right triangle right here. And I write down, I put the 87 down here. I'm going to use 55 here. Okay, I'm going to use this big angle here. The 55 comes with me there. And notice again 90 and 55, right? I add those up, take it away from 180 to get me the 35. And so now I have my pair. Now I'm able to solve using sine law, right? So you pair that up just like here. And then I'm going to use the 90 to help me find y. And there you have it. Okay, and then the next part was a little trickier. They're asking for this distance here, but you don't know what this is. So watch what I did here. I used sum of triangle, like if I use the 25 here, maybe I should highlight that. If you stick to this triangle here for a moment, 180 minus 90 minus 25, that gives me 65 right here. And remember, this is a straight line here. So you get to find this angle here. That's extremely important because otherwise you're sort of stuck, right? If you think about it, me drawing this out, if you only know an angle and a side, that's not good enough. You need to have at least one more piece of information. Once I find that that is 115, obviously I use the diagram that the question provided me with. Okay? That's how I came up with the 115 there. So you have that pair that I pair up, and then the angle 30 is going to help me to find the side across from it, and there you go. Okay. And then the last one here, the ramp question, and I think a lot of it here hinges on this equilateral triangle. The markings tell you that all sides are the same, and if equilateral triangle has all interior angles measuring the same, that's a pattern. Two sides are the same, two angles will be the same. In this case, all three angles are 60. That's extremely important. And we also know that if this is 7, so are all the sides, all three sides of that triangle in there are 7 all in all directions. Okay. So how's that helpful? Watch the first thing I did here. If you want to solve for side y, there's a straight angle right here, and this makes 180 degrees all around. So I took away the 50 and the 60 to give me, from 180 to give me 70 degrees. So this is very important to get me started. I used that here in my calculation. Remember, this is side angle side. So we use cosine law there. And I just take the root and answer. Next, when we go over to this ramp on this side, notice that there's this angle is already provided, so is that one. And the 7, we know that this is 7. And see, you have a pair there, and the 50 will allow you to solve for that unknown side right there. You set it up using sine law, and you get that the ramp is 8.71 feet long. Okay, hopefully this helped you to review for the test. All right.